A future architecture for information. Some current research aims at an architecture for information as opposed to an architecture for byte carriage. Such research is based on the observation that what people care about is not devices but content, information. People exchange content and create it for others to use. The device, for example, the computer, is a lower level aid to this task. Such a system would focus on such issues as efficient information naming, dissemination, retrieval, and authenticity. On the internet today, the authenticity and provenance of an information object is validated by where it comes from. For example, in today's internet, the only way a user can be sure that a web page that appears to be from CNN is legitimate is to try to retrieve it from CNN. Once it is retrieved, there is no trustworthy information associated with the page itself that captures and conveys the provenance of the information. If one user downloads a page and then sends it on to a second person, there is no way for that second person to be sure it is not a forgery. If the validity of the information were associated with the information itself, perhaps using some sort of encryption scheme to sign the information, then we could use a much richer set of mechanisms for information dissemination. This might include peer-to-peer systems, third-party caching, archiving and forwarding, casual user-to-user transmission via email, and so on. The richness would provide a network that was more diverse and efficient. An architecture for information would presumably include some means to name information. Current internet names, domain names, and addresses do not name information objects. Rather, they name physical endpoints. That is, computers attached to the edge of the network. The web provides one scheme for naming objects, the URL. There has been much research on other schemes for naming objects, ranging from IETF research on universal resource names and centrally managed schemes such as the handle scheme to highly decentralized schemes that allow users to pick local names and share them. All of these schemes imply some solution to the location problem. Given a name for an object, can I find the object itself? Some solutions to the location problem would involve a centrally managed catalog of objects. Some solutions would use a more decentralized approach, with location services run by different operators in different regions of the network. Some schemes would be completely decentralized, based on a requester broadcasting a request for an object until a copy is found.